Good afternoon, everyone. My name, like Sheldon said, is Sheldon. I'm a field engineer at SUSE. And today I'll be talking about pioneering the evolution of manufacturing with Kubernetes. I'll be going over specific use cases where we've helped, or going over a specific use case where we've helped a customer, Continental AG, with their journey for containers, well, from containers to Kubernetes. Shortly, I'll show you where they started from, which challenges they had, and how Ranch was able to help them achieve their goals. This presentation will have a bit more slides than I'm actually used to, but I'll try to keep it to the point and short, so I can also show you a demo of the solution they used, or a similar solution. In this demo, I'll give you a quick glance at Rancher and K3S and show you how and why the combination is so powerful for factories and scaling Kubernetes to the edge. And as last, we'll have some time for a couple of questions. So I think everyone that owns a car or has ever owned a car or a motorcycle knows Continental, since it's one of the best known tire brands in the world. However, Continental AG, or AG in German, as the company's name, is a lot more than just that. So whether it's autonomous mobility, vehicle networking and information, infotainment, or agriculture, they've been developing pioneering technologies and services for sustainable and connected mobility of people and their goods since 1871. They offer safe, efficient, intelligent, and affordable solutions for vehicles, machines, traffic, and transportation, which is somewhat exactly stated on their homepage, so you don't have to be a Google ninja to find that info. They're headquartered in the German city of Hanover, and they have over 232,000 employees in 59 countries. So yeah, I'd say it's quite a big company, and they've pretty much had 150 years of replacing legacy processes with the new hot thing. And that's why Continental's manufacturing infrastructure team exists. So they're there to reap all of the benefits of the latest and most disruptive technologies and to serve all application teams better and drive innovation in the company. There are actually three main objectives that drive Continental's strategy, and those are creating efficiency, maintaining the highest quality standards, and achieving this in a systematic and network manner. This is what the team believes is what helps them transform novel ideas into mass production faster. And so far, that strategy seems to be working just fine. So go agile, just do DevOps, containerize all your apps. That'll solve all your problems. Your team will become a well-oiled, no technical debt having, everybody can everything unicorn of a team. Right? I hope that didn't sound too sarcastic, because surely I meant that, right? So, well, no, it's not that simple. Try explaining that to the new guy that just came off of his DevOps bootcamp. But I digress. So, in manufacturing, especially, the practical implications of modernizing legacy infrastructure and all software that runs with it cannot be underestimated. Continental ran virtualized infrastructure for many years. Over time, management and maintenance became problematic. So if the team wanted to implement a new feature or upgrade an application, this took quite a lot of time and resources. So when containers popped up a few years ago, they saw an opportunity to streamline infrastructure management and started to investigate it. It took a couple of years for the discussion to begin about the value of containerization, but once it did, the team also quickly identified Kubernetes as the most flexible way to containerization, the containerization step, as the most flexible way to get that containerization strategy off the ground. When their plans actually started to crystallize in 2018, they looked at whether to move all applications to the cloud or remain in the data center. Running Kubernetes in the cloud was quite easy with AWS and Azure. However, critical applications like factory machinery that required millisecond response times needed to stay in the data center. So the team needed a hybrid cloud and on-prem solution. Needing an on-prem and hybrid cloud solution meant they would have to engineer and support their own solution, which of course would have taken a lot of time. The primary driver for adopting a cloud-native container-centric strategy was a need to transform their manufacturing infrastructure into an agile, cloud-native, and platform-based architecture. It had to be heterogeneous and flexible to run on-prem and cloud workloads together with any vendor via a central UI. So that's where Rancher came in. After a short POC in 2019, where the team also evaluated other Kubernetes management solutions, Rancher emerged as the most suitable platform to help modernize and unify Continental's legion of manufacturing applications. After Rancher won the Kubernetes management platform wars, which by the way is the worst action movie name ever, there has been a growing demand from Continental's many manufacturing teams. Now the focus has shifted to make the platform available to hundreds of application development teams across the world safely. And for them the change couldn't come soon enough, since the maintenance had become so resource intensive over the years that it really slowed the pace of innovation drastically. More importantly, many production lines run 24/7, and if an infrastructure or application component needed upgrading or patching, taking it out of service would cost the company a lot. So the team needed an environment that allowed them to develop and maintain manufacturing apps without affecting productivity. Rancher with Kubernetes, with Rancher and Kubernetes, the team has created a highly agile and scalable application framework, which has removed complexity and significantly reduced management overheads. So they can now run applications in separate clusters with development, test, and production environments ready and in place. Spinning up new containers to try new ideas in whichever area on whichever infrastructure is done in minutes. Updating apps or performing maintenance can be done using Rancher without halting production lines. This means that no costly downtime windows are needed and updates are centralized and installed in a few clicks. The team at Continental estimates their management times have been reduced by about 75% because the platform promotes a cloud-native approach to building and deploying new services and applications. And again, all of this from one single pane of glass. In manufacturing, it's common to have large, resource-intensive servers running next to the shop floors. These are expensive to run and outdated. By making manufacturing apps to be more cloud-native, the team will be able to reduce costs by moving applications to the cloud and data center, where compute resources still needed in the production lines. IoT solutions like K3S will allow the team to run those lightweight versions of Kubernetes directly on the machinery. Of course, hardware transformation takes time, but putting the right infrastructure in place now, the path to wider transformation will become much smoother. Continental also estimates an 80% reduction in migration time, where comparing methodologies, and 80% reduction in upgrade time, making upgrades possible in hours instead of days. They also predict to have significant cost reductions by moving the on-site server applications to the data center and cloud. And last but not least, they now have a global management platform for 45 regions and hundreds of developers that's accessible 24 hours a day, 7 days a week, with access tightly monitored in Rancher. So I'm right on time. I'll quickly show you a bit of Rancher and K3S as well. So the solution that they've been using to allow that transformation. Rancher itself a multi-cluster Kubernetes management solution, completely open source, and we really stand for no vendor lock-in. So everything you see me do, you can just start playing around with it immediately, because what you see is what you get. Just go to Rancher Quick Starts, and then we have multiple ways of you to just get started and playing around Rancher, right? So Terraform scripts to deploy Rancher in AWS, DigitalOcean, with Vagrant. We really want to make it easy for you to just start playing with it. And the simplest way is even to just do a Docker run of the image of Rancher's image. However, if you do play with it, with the Docker image, that's fine for testing, but we really recommend to use Kubernetes as its underlying layer, because then Rancher can be HA, and it's a lot more flexible to upgrade that test environment to a more, well, dev or acceptance environment. Of course, always built for production from the start. This, as you can see here, is the Rancher login page. So this is just a quick, actually, I know how simple Rancher is, but just 30 minutes before the session, I actually broke my Rancher. So I had to spin everything back up. So I actually have a different URL that I'm now using, or a different hostname. But I spun it back up in 15 minutes and set up the whole demo again. So again, happy with how simple it is. If you just spin it up by default, you get a local user, a local admin user, just admin and a password. When I log in to the console, I can, when of course with a large organization, I can, for example, set up authentication. So if I want to connect my AD or LDAP or whichever one is on this list, and it's a pretty exhaustive list, you can connect that central authentication backend to Rancher. Once all those users have been imported, or basically whatever groups view that import, or all of them, of course, the users will be available in Rancher. You can give them certain roles from a very high level to a very low level, down to the namespaces themselves. And all of this is managed from your central auth. So adding new users, adding groups, and all of those things, that all happens in your AD, for example. And Rancher just pushes that information to any cluster that it manages. It's also extremely important to note that indeed every cluster that Rancher manages, all of the information or all of the RBAC that is pushed to those clusters is Kubernetes native RBAC. So for example, this DEVOPS con HA cluster, if I want to communicate with this cluster, even though it's on DigitalOcean, it might be somewhere else, I can just get my kubeconfig file with, well, a Kubernetes native way of communicating with my cluster, or just from the UI, of course, do a one-off command and just quickly check something, for example. However, most use cases, you'd probably just get your kubeconfig file and use your own local terminals. And this is there for every type of cluster. So whether you import an existing cluster, whether you register an existing EKS cluster, which gives you full lifecycle management of an EKS cluster, or whether you use Rancher to provision Kubernetes on top of existing nodes. For example, the reason I just accidentally broke my own Rancher is because I imported a cluster, or I tried to provision a cluster on the container that I'm using to actually run all of the commands to this environment. So I accidentally ran a couple of kubectl commands to this Rancher node and kind of imported itself. And so it was just a stupid mistake. But if I have a machine laying around, or I have my own laptop, or whatever I want to do, I can just use this to create a node provision a Kubernetes cluster from an existing node. I can also just use the cloud drivers, of course, the node drivers, where I can basically in EC2 or Azure Compute, or in my case, DigitalOcean, spin up and provision Kubernetes using the cloud VMs. And also I can even create hosted Kubernetes environments from Rancher as well. These options in the bottom are actually not even all of them. So if I, for example, go to drivers, you'll see that there's even a lot of cloud drivers and node drivers just disabled. So these are just the ones that by default are actually on. quickly, just to show you how easy it is, and staying in the manufacturing lane, of course. If I want to create a lightweight Kubernetes cluster, because I've got some machinery, I've got maybe an ARM a machine with ARM architecture, ARM64, and I just want to add that, well, as a cluster to my Rancher instance, and then I can manage that Kubernetes cluster for whatever machinery or hardware is connected to it. All you would need to do is go to k3s.io to see how to install K3s. It's actually super simple if you don't change anything, because you can add parameters to this command, or now you can also create a config file where then just running this command will then use the configurations that you set in the configuration file on the node. I won't do any of that. I'll just copy this. Don't be scared. I'm going to open the terminal quickly. This is actually my Raspberry Pi. So it's ARM64. It's running Ubuntu OS. And let me see if I can show that as well. Right, so Raspberry Pi, ARM64. And currently, I think K3s is not running on it. So if I just want to install a lightweight Kubernetes cluster, all I have to do is, well, paste this command. It'll run an install script. This install script is going to download the binary, set up a few useful symlinks, give me a few uninstall scripts as well, or an uninstall and a kill all. So if I broke something and I just want to uninstall everything quickly and make sure that nothing gets left behind, I can just use this uninstall script. If I want to just stop everything but not delete all of my information, I can just use the kill all script. And this also, of course, then starts the K3s agent, and well, now a Kubernetes cluster has been created. So if I want, for example, I can, like I said, a few useful symlinks. So I can already, for example, let me do kubectl git node. This is then, well, an already single node Kubernetes cluster that I can start using. And it's, well, that simple. K3s also installs a bunch of things for you. So by default, it is an opinionated lightweight Kubernetes distro. So you get, for example, core DNS, a metric server. You actually get a local path provisioner as well. So if you want to start deploying persistent volume claims, you can. So if I would now deploy an application with a PVC, it would dynamically create a storage APV for me from the local storage. So using containerd by default. So there's a bunch of differences in K3s, which I'm not going to go into because that's a complete talk by itself, but it's super useful and especially created for resource constrained environments, and it runs on, well, any architecture. I've just created that cluster, so all I want to do is just import and manage it with Rancher. So I can just go to add cluster, import a cluster. I'll just name it Raspberry Pi, something like that, create. It's going to give me a few options. So either insecure or secure. Well, this is using Let's Encrypt. So it is using a known CA. So I can just copy this, go back to my terminal. I'm going to do sudo because by default K3s sets permissions which don't allow, for example, this user to just use the kubeconfig file. So I'll just put sudo in front of it. And all this is going to do is install the resources necessary for Rancher to then deploy its agents. So for example, sudo kubectl git pod. You'll see that, let me increase this a bit. All it's installing is a cluster agent, and there will be a node agent for every different node. And that's all that's actually being installed in this cluster. So any existing clusters that you have, you can just import them into Rancher. As soon as you import them, then those clusters will then also be available and use the RBAC that you set up. So any user logging into Rancher will now have access, or won't, to that cluster with whatever permissions they have. So if I just go back to Rancher quickly, I think it should be done by now. Or it's pulling the images and it's just taking a bit more time on my Raspberry Pi. Doesn't matter. I'll just click done for now. If you want to import a cluster, it's that easy. If you want to create clusters, it's super easy. For example, if I just want to spin up maybe Kubernetes version 1.21 is out, and I just want to quickly test a new feature for that version, I would select maybe one of the cloud VMs or an existing cluster, or at least I want to deploy a cluster. So I'll just select the one I have credentials for. I just want to quickly do a test. It's just one VM, so let me just tag it with my initial test. Then I can select the template. This is just the way you would configure a VM in the cloud, right? So what size, how much memory, which availability zone, all of those things you can do, right? So with your specific credentials for whatever type of cloud provider you're using, you would get some choices between, well, whatever's available, of course. That template you just create once. And as you can see, I've got 3 templates pre-created. And then I can just use those templates as well. So if I just want to quickly test a new Kubernetes version, I just use one VM, 2 CPU, 8 gigs, and then I give that single node all 3 roles. So etcd, control plane, and worker will be available on that single node. It'll be the latest version because then, well, that's going to be automatically updated in here. Won't have to do anything else, just click create. And this, with my credentials, goes to that specific cloud provider and creates a Kubernetes cluster for me. Here, for example, I have a highly available cluster. So instead of just a simple 1 node, I have 8 nodes. So if I just edit this cluster, for example, you can see that in this cluster, I have a control plane. I've got 2 control plane nodes, 3 worker nodes, and 3 etcd nodes. So these are all completely separate. Anything goes wrong with a control plane component or one of the etcd components, nothing will affect something else. So I can create a highly available cluster like this. If for whatever reason I want to just add more nodes, because for example, I've got 3 nodes in here, they're in Amsterdam, 2 CPU, 8 gigs. If I want to increase the size, or I need to add more workloads or whatever, or I want to have a node in a different region, I can just add a new node pool. Let's call this conf extra. I'll just do one of them, and then I just select a different template. So now maybe 4 CPU, 16 gigs, and in London. It's already a worker, so I just scroll down, hit save, and this is going to now add a node in a different region to my already existing cluster. Super simple and well, super easy to manage as well. In the meantime, of course, this Raspberry Pi cluster is also done. So I can, for example, if I click on this, I can see the node is Ubuntu, well, the user is Ubuntu. And if I check out the system information, it's my Raspberry Pi. That's all fine. Since it's Raspberry Pi, ARM64, I could also, if I don't want to use the local storage provisioner, I could just go in and deploy a more full-fledged storage solution called Longhorn. I can just go in. Of course, here I can see all of my workloads. I go to the apps marketplace. These apps are available for everybody that has access to this cluster. So they're just Helm charts. So if you just create your own Helm chart repository, you can just easily add in your own Helm chart repositories and then provide access to this cluster to a specific user. And they can maybe only see a specific set of applications to deploy. So you can make your own applications from maybe in your ops team and then provide them to DevOps teams or something like that if you'd like to. They're just Helm chart applications. So if I would just, for example, I want Longhorn, just click Longhorn. I don't have to change anything else, but I could just hit install. And this is going to install a Longhorn, which I'm not going to go into, but I would highly recommend looking into it if you want a storage solution natively built for Kubernetes, right? So, and then I won't even go into continuous delivery and GitOps and all of the things that you can do from here as well. Just know that this environment allows you to see all of the resource, any custom resources, everything you have in your Kubernetes cluster, in any cluster, and then you can set security rules, RBAC, all of those components on a high level from one central pane of glass. And for example, easily upgrade and do all of those things as well. So that's it for the demo, for all of the time I actually have. Let me just while all of this is just working, let me open this again. And final remark. So you quickly just saw me demonstrate how easy it is to set up a lightweight Kubernetes cluster, import that into Rancher, and create a couple of clusters. All of those clusters are now managed by Rancher, and I can centrally manage all the clusters. You just saw me quickly all of the features from that one central place for all of those clusters. Rancher is a simple, no vendor lock-in solution that allows you to leverage the full power of containers and Kubernetes from one single pane of glass. It provides a platform for you to run cloud-native apps on any infrastructure and allows teams that may be separated geographically and or by business unit to work together in a unified and consistent way. More importantly, they can do it safely with a rules-based domain, within a rules-based domain. And this gives you a scalable, agile framework where collaboration and cooperation can reign. So I went over a minute, but are there any questions, Landa and Sille?
Yeah, thank you very much, Sheldon, for the presentation. It's good to understand how technology helps also the transformation here. Yeah, we have a few questions, so let me start now from the other way around. So from the last one, how well Rancher control plane handles poor connection to target environments?
Sorry, can you repeat that?
Very specific question. So how well the Rancher control plane handles poor connections to target environments?
So that would depend. So like you saw, there are multiple types of clusters you can create. If you have a cluster that, for example, has more restrictions, so you can, for example, use SSH for Rancher to provision a cluster. You could just create a cluster on that location yourself using K3S or RPE, and then you can import that cluster to Rancher. The import itself is just going over 443, so HTTPS, but the different types of clusters you have can have maybe different requirements for network access.
Very good. Thank you very much. There was another question like, is there a limit about how many nodes can K3S support?
K3S, no. So that's, well, the limit is what Kubernetes supports, right? And I think was that about a couple of hundred thousand or something. So we will never reach that limit. And I would say K3S is meant for smaller clusters. So I wouldn't add that many nodes. I would rather go with a single cluster instead of hundreds of nodes, basically. So hundreds of clusters instead of hundreds of nodes.
Staying with numbers, so what is the number of clusters when it's really worth to use the Rancher for managing them? So when you say at scale, what is that scale? How big is it?
Yeah, so it's like I've thought of these questions myself, but good question. It's actually, so in 2.4 we had support up to at least 2,000 clusters, but as of Rancher 2.5 we actually have support up to 1 million clusters. So that's why we also have the DEVOPS solution in Rancher now, continuous delivery, where you can manage all of the deployments to all of those different clusters and the resources on the cluster. And if you, for example, were to log into any one of those clusters and change a resource, you would get notified in Rancher as well. So we really, with 2.5, we really made it to scale up to 1 million clusters.
Very good. Thank you very much. So yeah, like funny question, or at least like a curious one. Why did you kill Rancher OS?
Rancher, yeah. So the problem is it wasn't, a lot of people loved Rancher OS. And I myself, when I started at Rancher, it was super simple. But Rancher OS is a container OS. So when you want to use it for Kubernetes, you start to need other things in your OS, right? Certain kernel modules, maybe some storage modules and stuff like that. So Rancher OS was just not made for that. So that's why we had to eventually just kill it. But we are working on a new minimal OS within SUSE, which should be coming up quite soon.
Very good. And maybe the final question, a bit not so technical. So how you get the management to get interested on these enablers? What's the sales story for that, setting the idea?
I would say contact us so an AE can explain, but no. So like with Continental, it's the management reduction time. It's allowing your teams to move quickly, innovate faster, being able to do upgrades and all of those things without having downtime, doing zero downtime upgrades of your Kubernetes environments. All of those things add up to less time spent on maintenance and ops, and more time on developing new features for business and more money.
Very good, very good. Thank you very much, Sheldon, for your presentation. It's good to learn all the technology behind. Thank you for the case study.